Hey everyone, and welcome to this explainer. So, have you ever stood in front of your medicine cabinet with just a pounding headache, staring at a bottle of ibuprofen and a bottle of aspirin, and wondering, which one do I actually take? Right? We have literally all been there. Well, today, we're going to decode that medicine cabinet. We're going to break down the totally fascinating science behind these two ubiquitous pain relievers and find out exactly what happens when you swallow that pill.
It's easily the single most common question people have when they reach for a painkiller. Are ibuprofen and aspirin actually the exact same thing, just, wrapped up in different packaging and marketing? Well, the short, definitive answer is no. They are absolutely not the same medicine. But the reason they're different and the mysterious biological components they actually share is just a fantastic story of chemistry that happens right inside your body.
Section 1. What they share. Important similarities.
Okay, let's dive right into what these two medicines actually have in common because they do share some pretty incredible underlying traits. Looking at the building blocks of these molecules, we find our first massive similarity. Both ibuprofen and aspirin are constructed entirely from just three basic chemical elements: carbon, hydrogen, and oxygen. That is the whole shebang. It's a really great reminder that these highly effective medicines don't rely on some rare, crazy compounds, but rather just the foundational building blocks of the organic world.
Now, beyond their foundational ingredients, they also belong to the exact same family of medication, which are known as NSAIDs. This stands for non-steroidal anti-inflammatory drug. Basically, what this means is that both ibuprofen and aspirin are designed to stop inflammation in your body. But crucially, they do it without using steroids. They aren't like prednisone or other heavy-duty steroidal medications. They use a completely different mechanism to calm things down.
And because they belong to that same NSAID family, they share the exact same primary benefits. Both of these drugs are fantastic at relieving minor pain and stopping inflammation. So if you twist an ankle or maybe you have a mild headache, either one is going to go straight to work on that pain and swelling. And honestly, this is exactly why it is so completely understandable that people mistakenly think they're the same drug. I mean, when you take them for the exact same reasons and get really similar baseline results, it's incredibly easy to assume they're just identical.
Section 2. The crucial differences. Diverging effects.
Now, let's pivot from those shared traits to the critical areas where these medications wildly diverge. Remember how we just said both drugs are made from carbon, hydrogen, and oxygen? Well, here is the incredible narrative twist in our chemistry story. It is all about the architecture. While they use the exact same atoms, the structural arrangement of those atoms is completely different. Imagine having the exact same pile of building blocks, but using them to build a boat instead of an airplane. A simple rearrangement of the identical atoms creates an entirely different molecule. And because the molecule is shaped differently, it behaves differently inside you.
When we look at their specific features, we can see exactly where aspirin and ibuprofen diverge because of that unique structure. As we already covered, yes, they both stop inflammation and relieve minor pain. But there are a couple of areas where aspirin really stands apart. Aspirin actually prevents the clotting of blood, whereas ibuprofen doesn't have this as a primary effect. On top of that, based on our source's main focus, aspirin is highlighted for its specific ability to reduce fevers fairly well. So if your primary symptom happens to be a high fever, understanding these distinct features shows exactly why aspirin might be a really good choice for your specific situation.
Let's actually pause and look a bit closer at that blood clotting detail, because it carries real-world, high-stakes health implications. Because aspirin prevents your blood from clotting, it can be a literal lifesaver in the right context. If you're worried about blood clots or you have constrained arteries, taking aspirin can be incredibly beneficial. It literally keeps the blood flowing. But on the flip side, if you're someone who is prone to bleeding, you really do not want to take aspirin. It'll make it difficult for your body to form the clots you naturally need to heal a wound. It's a perfect example of why knowing the difference between these two drugs truly matters.
Section 3. Names and history. Aliases and origins.
Let's see how this chemistry translates into the everyday brand names you see in the store, and the surprisingly disparate histories behind these two medications. When you're walking down the pharmacy aisle, the names can get a bit confusing. Ibuprofen is basically a master of disguise. It goes by several very popular aliases in the medicine cabinet, like Motrin, Advil, and Nurofen. Those are all just commercial brand names for the exact same ibuprofen molecule. Aspirin, on the other hand, is a bit more straightforward. While there are different brands that sell it, it's pretty much always just called aspirin, right there on the front of the box.
But aspirin does have one super secret alias, its formal chemical name. And this brilliantly illustrates the complex chemistry we've been talking about. Aspirin is sometimes called acetyl salicylic acid.
Go ahead, try saying it with me. Acetyl-salicylic acid. It's actually quite fun to say, honestly, even if it feels like a bit of a tongue twister. But beneath that complex name is a drug with a surprisingly deep history.
When you look at their discovery timeline, the age difference between these two everyday drugs is just staggering. That tongue-twisting acetylsalicylic acid, aspirin, is a significantly older drug. It was discovered and utilized as a medicinal drug way back in 1853. Ibuprofen, by contrast, is a relative newcomer to our medicine cabinets. It was discovered over a full century later, in 1961. Yet today, both of them sit side by side on store shelves, offering you two totally distinct ways to interact with the molecules in your body.
Section 4. Why structure matters? The conclusion.
So, what does this all mean? Well, this brings our entire explainer to its overarching scientific takeaway. It all comes down to the architecture. The big takeaway from all of this is that the way atoms are arranged dictates exactly how they will interact physically and chemically inside the human body. Ibuprofen and aspirin are not the same thing. They use the same three ingredients, yes, for sure, but because those carbon, hydrogen, and oxygen atoms are arranged differently, they become fundamentally different tools. And that structural difference is exactly what gives them their unique chemical and physical properties when you swallow that pill.
So armed with all this new knowledge, think about what's actually happening next time you have a headache, a fever, or a swollen ankle. You aren't just grabbing a brand name. You are selecting a highly specific, microscopic architectural arrangement of carbon, hydrogen, and oxygen atoms designed to do a very specific job in your body. So next time you reach into the medicine cabinet, which molecular arrangement will you choose?